So when we're looking at the limit, looking at the limits from a graph is easy. Did you think that that homework was taxing? A little confusing when it was the drawing and maybe left and right stuff. But for the most part, if you're looking at your limit coming from one direction and your limit coming from the other direction, even if that point is not defined, we know that the limit as x approaches 3 from the left and the right is equal to this output value of 4. Not a problem. If we have a table of values, that's pretty easy to see too. Because when I look at my x value getting closer and closer and closer and closer to 3 from both the left and the right side, I can pay attention to what my output value is getting closer to from the left and right side and make a pretty good guess that this table would have a limit of 4. So looking at the graphs and looking at the tables, how does that remind you of the homework that you did for both your projects and for 2-1, where you had to type all those numbers into the calculator? Turn and talk to your partner and see if you can think about how the limit might apply to that conversation. Go ahead. All right, so the homework in 2-1, if we go all the way back to the beginning of the unit, that's where you went ahead and you looked at what a value was approaching. That's what you looked at when you put each of these values in, and as you got closer and closer, and Billy and I had an interesting conversation about what values you want to be putting in, getting closer and closer and closer to each of these numbers. You were actually calculating limits there, which is exactly what we are continuing to talk about here. So when we're talking about coming up with these calculations, we're talking about using algebra to be able to figure out those limits. How's it like your Euler project? Your Euler project was where you determined E was that limit, and you did it by using algebra. Today we're going to do an awful lot of algebra, so buckle up. The one thing you need to know, if the limit is given to you as a constant, then that is your limit. Now you may not know what the function is. So this here is some rule named F, some rule named G, and I don't know what the rules are. I don't care what the rules are, because they're telling me as x gets closer to 3 from the left and the right, the output is 4. That's the limit. That's what we're approaching. As G gets closer to 3 from the left and the right, my output is 1. Here's the cool thing. We can add and subtract and multiply and divide and do all kinds of calculations with these limits. So one of the things that you're going to be asked to do is to take the given information and process it. All right. So first of all, make sure that your limits match the limit as x approaches 3 for f and g. And you can just go ahead and substitute and simplify. So twice the limit of f of x plus the limit of g of x will satisfy what they are asking you to do here. 2 times 4 is 8. 8 plus 1 is 9. Take a look at B. What do you think the value of the limit as x approaches 3 of the ratio of g of x to f of x is? The value as x approaches 3 of g of x is 1. The value of x approaches 3 of f of x is 4. The ratio of the two of them is 1/4. Plug and chug. We can also find limits algebraically. If the The limit is asking for a y value as the value of x is approached from the left to the right. That answer to the limit questions is an output value. It's what it is getting closer and closer. When possible, you want to substitute that x value into the function and then go ahead and simplify. So these examples have nothing to do with example 1. These are all separate on themselves. If my function is not predefined for me, this is different from saying this function's limit is 4. Now I'm saying the function is 3 times my input value. All I need to do here is plug my input value and the limit as x approaches 2 of 3x is going to be 6. My limit as x approaches -1 of 7 times that input value plus 2 is going to be -5. My limit as x approaches pi is 2 times the cosine of pi minus 3 times the sine of pi. This is where we expect you to know your unit circle. We expect you to have the value of pi at the front of your brain. Oh, heck no. We expect you to know that the cosine of pi is, say it out loud, please. The cosine of pi is -1 minus 3 times, what is the sine of pi? 0. Which is going to give me a value of -2. We can also find the limits of logs. What? Will the fun never end? If I want the limit as x approaches e of the natural log of e, you know what this is. Yes, you do. What exponent goes on e to give me e? 1. The natural log of e is 1 needs to be in one of those things that you know, like, you know, your phone number. Do you know phone numbers? All right. Flip the paper over. We end up with these things called piecewise functions. And piecewise functions are similar to what we've been kind of looking at, where we have, it's unrealistic to think that everything always has this constant rate or slope. So when we end up putting our input values and our real life stories on the coordinate planes with our x values, the functions end up changing. So we have pieces of things. So what I want you to think about is this number line. And on this number line, I have this story of -5. So anything, any input value that's greater than or equal to -5 is going to follow this rule. Any input value that is less than -5 is going to follow this rule. That way you're not confused about what to do if x is equal to -5. See where the dot's colored in? That's the one you use. So the story changes at an input value of -5 with our piecewise function. Okay, so what we have to pay attention to is where each of these limits are coming from. And notice I'm back to having limits from the negative or the positive side. So as x approaches 5 from the negative, I'm going to be using my function, the square root of 11 minus, and it's going to be that input value. So you're going to put that input value in for x in the function. 11 minus negative 5 is 16 squared. 16 is, so this limit has a value of 4. The limit as x approaches 5 from the positive, negative 5 from the positive, is going to be when I put negative 5 into this rule now. So I have negative 5 plus 3 over 5 minus negative 5 squared. In algebra, we always tell the kids to plug with a hug. So when we plug in those negative values, especially, hug them up with those parentheses to make sure that we don't lose track of our negatives. Negative 5 plus 3 is negative 2. 5 minus 25 is going to give me negative 2 over negative 20. You okay with that? So that's going to give me a value of positive 1/10. Okay. The limit as x approaches negative 5 from the negative side is 4. The limit as x approaches negative 5 from the positive side is 1/10. So what can I say about the limit as x approaches negative 5? Yeah, it does not exist. And it does not exist because these two limits are not the same. Sound okay? All right. So the next one, you're like, oh, it was all good till the e's got involved. So what we want to do is, again, and if it helps you to draw a little number line above to have a story of your input values, you can. You know, a number line is always just an x-axis. So we're talking about negative 1 as a value. We're talking about e as a value. And each of these stories exists in a different part of this input. So square root of 10 minus x squared is what I'm talking about here, not including negative 1. 26 minus 5x squared over 7 is what I'm talking about between here up to and including e. What do you notice about an input value of negative 1? I heard it. It's a whole, yeah, we're not talking about it. It doesn't exist. It is undefined. If I'm talking about everything greater than e, I'm talking about this function here, the natural log of my input value q. All right, with your partners, talk about each of these limits. I want to hear you talking. Go. All right. So if you look at the green part of the graph, when I'm looking at x approaching negative 1, because it doesn't have a plus or minus after it, I have to do both limits to determine if there is a limit. So when x is approaching negative 1 from the left, I'm going to use 10 minus x squared. So put negative 1 in. Negative 1 squared is 1. 10 minus 1 is 9. Square root of 9 is 3. You okay with that? That's what's in green right here. When I'm talking about approaching negative 1 from the right, I'm talking about this red function. Insert negative 1. Negative 1 squared is 1. 5 times 1 is 5. 26 minus 5 is 21. 21 divided by 7 is equal to 3. because these two limits match, I can boldly say that the limit as x approaches -1 on this piecewise function is 3, meaning these two different pieces are headed to the same value. So that's nice. Good for you, right? You're like, correct. There they go. They're headed to the same value. They're going to be friends. All right. When I look at B, the limit as x approaches E from the positive, that's my purple. I'm going to go ahead and I'm going to put E into that function. Don't be afraid of E. The natural log of E that gives me E cubed, what is the exponent on E that gives me E cubed? 3. That's 3. So you're so excited because you're like, look, this is 3, and this is 3, and this is 3, and this is 3. And then you go to do this one. As x approaches E, well, you already have the positive limit. You have to do the negative one. As x approaches E from the left-hand side, oh, that's a mess. I'm not even going to simplify it because it's not, I'll just leave it like it is. E has a value of 2.7-ish when I square it. It's going to be somewhere between 4 and 9, right? Times 5. Okay. When I subtract it, that's not working out pretty at all. Everyone okay with that? All right. So here we have some practice for you. And instead of doing this practice, we had an activity. So the very same practice questions. All right, so here's how this works. So hold on, let me get to this work. Okay, you're gonna put it like a hot dog down this line. Hot dog. That's a hamburger. Lord, who was your elementary school? How did you get?
So lofty. No, it's like not.
I know, I'm sorry. How did you get to your senior year of high school without that? Come back to back. I'm gonna call her and tell her I still talk to her all the time. Adrian, I agree with you. It's perfect.
No, it's bothering me. Yeah, it's bothering me. The back is deep. Okay, we're just the back then. Yeah, let's just
That's a good idea. It's bothering me too.
You need to do it all the way.
I will ask for your attention back.
Oh.
Alright. So what I want to do, and it's fine if we don't fold quite yet, because we'll do the first couple together, because partner two's limit is a little bit difficult, and I want to make sure you understand it. Okay, the way a Sage and Scribe works is like this, and you don't have to fold it if you don't want to, if it's freaking you out. If you are the partner closer to the window, you are partner 1. If you are the partner closer to the door, you are partner 2. That's an easy conversation to have. I'll get to it in a minute, Billy. Don't start talking. I want to get through our instructions. So the way that the Sage and Scribe works is you go back and forth and you alternate turns. So it's not like partner 1 does his whole side. You go back and forth and back and forth. Partner 1 is the first scribe. So you are writing in your column where you are. But you are only writing what partner 2 tells you to write. So when we look here, partner 2 is given these constants. We don't know anything about the f or the g functions other than the fact that if x approaches 3 or -3, these are our various outputs. The only thing that partner 2 has to be careful of when they are talking to partner 1 is this concept of the opposite of x. Because if you are plugging in the limit as x approaches 3 as of the opposite of x, you are actually not going to use the limit as x approaches 3, but you're going to use the limit as x approaches -3. because when you plug in the value of 3, do you see how now it changes my limit, what's being asked of me? Are you with me? So partner 2, be careful of that. This is asking for this limit, even though it says positive 3, it's asking for the opposite. Even though this says as x approaches positive 3 for f, it's asking for the opposite. That's where partner 1's is tricky. Partner 2, actually in partner 1 is pay attention because you're the one talking during this one. Yours is tricky on a whole different level. If you're given all these limits, notice I've got 2 and 1 and 4 and -2, and you're like, that's weird. As you plug your value in, 2 times x, you are actually finding the limit of f of 4, so you are looking here. Here, you're finding the limit of f of, when you put 2 divide by 2 in here, you are actually looking for the limit at f of 1, which is here. So when the x of the function is being altered, double, halved, or negative, it changes which limit you're looking for as the function. Does that make sense to you? So when partner 1 is saging, they need to keep track of what's happening to the x's. Opposite, divide by 2, double. When partner 2 is saging, they need to be careful of what's happening to the x and finding the double. Here's the idea. Are you ready? As you work down these, partner 2 is talking as partner 1 is writing. If partner 1 does not agree with what partner 2 is saying, they're allowed to go, are you sure? You want to check that? Because it's not your job to answer, but it is your job to double check that everyone's doing it correctly. True or false? Partner 1 will have his entire worksheet filled out before partner 2 starts. False. Because you're going to go on 1, 2, 2, 3, 3, 4, 4, 5, 5. You okay with that? Questions before I have you start? If you are partner 1, raise your hand. You are writing first. If you're partner 2, raise your hand. You are talking first. Turn to your partner and say, let's go. All right, so come back to me. So this is what I need you to think about. Nobody cares about the math until you can't do it. So it sounds like a cruel and evil thing that math teachers do, but we have to put you in the position of like, wait, what? I don't get it, before you're listening to the answers. Otherwise, you just sing along with the radio, writing down what the teacher says, and not thinking and learning and processing. So what we're having you think about is really understanding, really digging deep and scratching away at what is the difference between your input and output. So I want you to think about this one, for example. This means 3 times your output. Are you with me on that? So you want to find the limit as x approaches, what is it approaching? 3, right? The limit as x approaches 3. Okay, the limit of f of x as x approaches 3, that, my friends, is right here. What is the output as x gets closer to 3? 4. I want 3 times that. Oh, 12. Are you with me? So this 3 here is asking me 3 times that output value that you determined was the limit as x approaches 3. Okay. Over here, it's different. Because over here, before I get my output, I'm monkeying with my input. Remember when I said I want the limit as x approaches 2? I changed my mind. I want the limit as x approaches twice my input value. Oh, you mean 4? Yeah, I mean 4, which is going to have you looking at this conversation here. Thus the limit as x approaches 4. Now, can we have the limit, can I have as x approaches half of my input value? I was going to 2, and they're like, half of that, please. I'm adjusting my input. Here I'm playing with my output. Here I'm playing with my input. Do you see the difference? Whether it's inside or outside of the parenthesis with the x. 1 and 2 are where we don't know the function, but we're just told what the answer to the limit is. These were supposed to be the easier ones. Okay? When you look at question 3, now they're telling us the function, and we got to figure out our own limits. So your job is to plug in from whatever side. And if it helps you, like I said, if it helps you to draw a number line and keep track of whether you're talking about values smaller than 4 or smaller than -4, equal to -4, between -4 and 2, or greater than or equal to 2, that determines what value you're using. You with me on that? On the back of your sheet, these ones are quicker and easier. I put the harder ones first. Flip your paper over. The limit as x approaches 1 is going to be, or -1 is -1 squared minus -1 minus 6. Simplify that. Simplify that and you're done. -1 squared is 1. 1 plus 1 minus 6. That sounds a lot like -4 to me. You okay with that?
Yes.
Here's something that's crazy. Are you ready for this one? Where do I plug the 4 in? Where do I plug the 4 in? Ricardo's shaking his head. Kayla's like, I don't see a place to plug it in. That's because it's a constant. If I had a Hoy, do you remember your Hoys and Buxes? Do you remember your Hoys and Buxes? Yes? If I have a straight line as x approaches 4, it doesn't matter. My output's always 10. That's a constant value. Got it? Again, where I'm talking with my trig, the limit of the secant of 3 times pi over 4. Secant is friends with who? So the cosine of 3 pi over 4 is what you're looking for to then put under 1 and flip it reciprocal wise. 3 pi over 4 is our 45 degree family, so root 2 over 2, right? Root 2 over 2, when we flip it, becomes 2 over root 2. You've done that enough times to rationalize it that you know it turns out to be just plain old root 2. Let's think about positives and negatives. 3 pi over 4 is where? Right there. Is the cosine positive or negative? Cosine's going to be negative. So when I'm asking you for the limit, I'm asking you to substitute the value in for x and tell me what the output value is. And we're going to assume, because of these functions, that that is going to be the limit. Here we had different rules from a piecewise conversation about where the different input values did or did not change. These ones on the back are designed to be straightforward and easy. So you should be able to zip down these and figure out what these limits are, as you plug these values in, the log base 3 of 75 plus 3 times 2. The log base 3, 3 times 2 is 6. What is 75 plus 6? What is the exponent on 3 that gives me 81 as an output? Adrian said it. Didn't you just say it?
No.
Oh, I saw your hand in there doing this. I was so excited you knew it. It's 4. I saw you do that. Oh, she was just getting her hand out of her sweatshirt. Very convenient. The limit as x approaches 2 pi, the cosine squared of 2 pi. What is the cosine of 2 pi? 2 pi. 1. Right? 1 squared. You okay with that? Cosine squared. What is the cosine of pi over 3 squared? Pi over 3. What's my cosine? No. 100. Square it. 1/4. The limit as x approaches pi over 2 of the sine of pi over 2. Pi over 2, what's the sine? These are the easy ones, guys. What? Limit as x approaches pi over 6 of 3 times the sine of 2 times pi over 6. 3 times the sine of pi over 3. Pi over 3. What's my sine? Square root of 3 over 2. 3 square root of 3 over 2. See how we reviewed algebra first and that mattered? Yes? We also need you to be able to find the graph, using the graph to find the limits. Okay. And that's a review of what we did last time that you thought was easy. All right, your homework tonight is going to be, now, what I want you to understand is these problems here these problems here match the ones that are on your notes. So if you go back and hunt and pick, you can fill in those notes. Let me come around with your homework. And this homework is designed to help you get ready for your quiz next class. Did I say it loud enough? Did I say it loud enough? Quiz next class. Here.